This is the 2026 NECO Physics Practical Analysis. Do you want to get 50/50 in your NECO Physics Practical exam? Do you want to do the practical with ease? Do you want a practical that instead of spending the 2 hours 45 minutes in the exam hall, you spend just 30 minutes and you are done with the NECO 2026 Physics Practical exam? So if this is what you want, if you want 50/50 without stress, stay tuned. This lesson, this analysis is for you. In this class, in this lesson, in this analysis, I'm going to be showing you how to do your physics practical analysis. I'm going to show you how to do your physics practical exams without stress. I'm going to be showing you how to do the physics practical exams without stress. Yes, this is a secret that my students use. This is what I've taught them over the years. And that is why my students keep getting 50/50. They keep getting A1 in both physics and NECO exams because they know the secret. So if you actually want to do the same thing to get your 50/50 in this 2026 NECO Physics Practical, stay tuned and then I will carry you along. Just pay attention. Let's get started. If you look at this, what we have here, if you look at this, what we have is the 2026 NECO Physics Practical Instruction. You can look at that. You can see question 1. Look at question 1 here. This is question 1. Look at what they want us to bring. Look at the apparatus you're going to be using in question 1. You're going to be using rector stand, spiral spring. You're going to be using mass hanger of 40 grams. Then you have a set of masses, 20 grams, 40 grams, 60 grams, and 80 grams. And then you have a stopwatch. Okay, so these are the things you're going to be using for your physics NECO practical exam. Question number 1. For question number 2, you will need a rectangular glass prism, a drawing board, you will need a drawing pin, papers, you need optical pins, and then you need your thumb pins. These are the things you need for question number 2. Let's look at question number 3. For question number 3, you will be given resistance box. For question number 3, you'll be given resistance box. You have a key, you have a voltmeter that reads from 0 to 3 volts. You'll be given an ammeter that reads from 0 to 2 amperes. You'll be given connecting wires. Then you're going to either be given for this, you either be given 2 volts accumulator or 2 1.5 volt dry cell. The dry length cell is our normal tiger head battery. So you are going to be given 2 of that, or you are given 2 volts accumulator, the lead acid accumulator. Okay, so let's see what the question will look like for question number 1. Let's see. Now, this is what we have for question number 1. Look at them carefully. This is what we need for question number 1. If this is what we need for question number 1, the whole of this, that means that we are not asked to provide a meter rule here. And if we are not using a meter rule, that means this practical is actually purely on calculating the time for oscillations. So let's go quickly. Now, your question number 1, this will be the setup. You can see the rector stand here. You can see the rector stand. You can see this is spiral spring, this one here. These are the masses you're going to be hanging on the spiral spring, and then with your stopwatch, you're going to be counting the time for 20 oscillations. This is your setup. But stay tuned, because in this class, I'm going to teach you how to do this practical without this setup. How you can do this practical without touching apparatus. That is, I know it shocks you. I know it's like, is this possible? But that is what my students have been doing over the years, and I keep having like something A's in my physics exams, both NECO and WEC. So pay attention to this. You don't actually need to set up this. Don't actually need a teacher. You don't actually need a setup to get your 50/50 in these practical exams. So let's proceed. These are the instructions. These are the things you are supposed to do for question number 1, NECO 2026, question number 1, physics. You have been provided with a rector stand, clamp, a mass hanger, a set of masses, a spiral spring, stopwatch, and other necessary apparatus. You have been given these things. And look at this, they say use the instruction, the Using the diagram above as a guide, carry out the following instructions. Suspend the spiral spring vertically as shown in the diagram. So let's go back to the diagram. We asked the spiral spring, we are asked to suspend it vertically as shown. So you do this. Now the next thing you are going to do is, if you suspend it, you are going to hang, it says suspend a mass hanger of 40 grams. You are told to suspend a mass hanger of 40 grams on the free end of the spiral spring and the whole of these things. But now going through this question is like a waste of time, because I'm going to show you how to do this experiment without the setup. You don't need this setup you are seeing here, you don't need it. So let's proceed. We're going to be picking from this instruction, we're going to be picking the things that we need to get, the things that will be on the table of values. Okay, we are working with mass, so one of the things that will be on the table of value is mass. So we have mass on the table of value, and then we are to also determine time for 20 oscillations. So we still have t, small t, on the table of values. And then after finding the time for 20 oscillations, after finding the time for 20 oscillations, we have to determine t, we are asked to determine t, the period of oscillation. So capital letter T will be on our table. And then we are asked to evaluate t squared. So we're going to have t raised to power 2 also on our table. So our table for this question number 1, we have 4 columns. A column for mass, a column for small t, a column for capital T, which is the period, and a column for t squared. Now let's go and see how the table will look like. So this is a sample of the table. These are the masses given to us. Please pay attention, because we are told that the mass hanger has a mass of 40 grams. So this is the first 40 grams here is for the mass hanger. So look at what I'm going to do. I want to show you a secret that we're going to use to fill up this table. Please, if you have not subscribed to my channel, I encourage you to subscribe, because there are other things, there are other videos I've made that will help you on other subjects like chemistry and biology. Please try as much as possible to subscribe. Okay, so let's see this table. We have been given the mass. The first mass we are working with is 40 grams. Now, for the period of oscillation of a spring, because we are working with a spring, the period of oscillation of a spring, T, is given by the formula 2 pi square root of m over k. That is the period of oscillation of a loaded spring. T here is the period. K is a spring constant. Ym is the masses we are hanging. M represent the mass we are hanging. Okay, so if that is the case, I can decide to square the whole of this. If I square the whole of this, I'm going to have that t squared is going to be equal to 4 pi squared m over k. So if I square this is what I'm going to have. Now, this is the formula we're going to be using to fill this table. So you can see that you don't actually need the experiment. So let's go. For the first mass, which is 40 grams, this 40, we have to convert it to kilogram. We have to convert it to kilogram. So how do we convert 40 to kilogram? You divide 40 grams by 1000, and that will give us the value in kilogram. So let's proceed with this. Let's substitute our values and see what we're going to have. This is the equation we are using. So let's go. This will be equal to 4. Pi is given to you as 22 over 7. So 22 over 7 is something as 3.14 or 3.142. So I do squared. I square it times. Now this mass here, which is 40 grams, the first mass, we are converting to kilogram to get 0. To get 0.04. Okay, 0.04, sorry. To get 0.04 kilograms, 0.04 kilograms. Okay, so the mass I'm using here is 0.04. The mass I'm using here is 0.04. So I do 0.04. So I divide this by k. Now, how do we get the value of k? How do we get the value of this k? There is a secret I need to show you. You are asked to work with a spiral spring. You are asked to work with a spiral spring. A spiral spring has a range of spring constants. K is called spring constant. So in this derivation, we're going to use K as 17. We're going to use K as 17. Please take note, spiral spring, the spring constant can range between 10 to 25. So we're going to use 17. If you use 16, you are going to be correct. So we're going to use 17. But remember that our mass has to be converted to kilograms. So if I put the values, I'm going to have 4 times pi squared. You were told to use pi as 27 over 2. I mean, as 22 over 7. You are told to use pi as 22 over 7. So if I do that, just press your calculator. 4 times pi squared times the mass is 0.04. Then you divide by square constant. We're using 17. Okay, so let's use our calculator to do that. And if we use our calculator to do that, 0.0929299. Okay, so this is what we have. If we come to fill the table for t squared, so we come here to fill the table for t squared. We come here. Our t squared, don't forget, t squared is calculated, is a calculated value, so must be to at least 4 decimal places. Don't forget. Put 0.0928, 29 rather. So this is the value I'm plotting that for our t squared when the mass is 40 grams. When the mass is 40 grams. Okay, so how do we find t? How do we find t here? Remember, t should be the square root of t squared. So what I'm going to do is I'm going to do square root of 0.0.0929, and that will give me 0.3. T is a calculated value. Please don't forget at least 3 decimal places. Every calculated value should be written to at least 3 decimal places. So I can write this as 0.305. 0.305. Okay, so let's see how we can find, this is 3 decimal places I've used. Let's see how we can find small letter t. Now to find small letter t, remember the period of an oscillation is the time taken over the number of oscillation. The number of oscillation. That means this time taken will actually be the period times the number of oscillation. So this is the formula we are going to use to find the time taken without doing the experiment. And now, so the period we got is 0.305. So we are carrying out this experiment for 20 oscillations. So our n is equal to 20. Don't forget. So I'm going to do 0.305 times 20. I multiply by 20. And that will give me 6.1. So my time here is 6.1. 6.1. Okay, t, small letter t is a measured value. So measured values are supposed to be written to at least 1 decimal place. So if you write 6.1 here, if you write 6.1 here, you are correct, at least 1 decimal place. But there is something you need to know. If since I've started with 1 decimal place here, everything I have to do under the column for t will have to be in 1 decimal place. And then since I've used 3 decimal places for t, capital letter t, which is our period, everything here under it has to be in 3 decimal places. And since I've used 4 decimal places for t squared, everything under it will be in 4 decimal places. That is just that. Now let's try this. I want you to try this. I want to do the second one, and then I would like you to do the other ones yourself and fill the table. So let's go. Now, if we still apply the same formula, when the mass is 60 grams, remember we convert 60 grams to kilograms. So the actual mass we're going to use 0.0. We're going to use 0.06. That is the actual mass. So we still put our formula t squared is equal to 4 pi squared times M over K. Remember, we're using our K as 17. That is the value of K we are using. It is a typical value, so you're supposed to do that. Now, let's do this mathematics again. So we do this mathematics. I have 4 times pi squared, 4 times pi squared. Then whatever I have, I multiply by 0.06, 0.06. Then I divide by 17. I divide by 17. So I'm getting 0.0444. So the p squared is going to be 0.00444. 0.0444. Okay, please don't make mistake. What I have here is 0.0444. Okay, four. You can see 4 decimal places here. Now let's work out the time. Let's work out the period. Now for the period, what we're going to do is to find the square root of 0.0444. So what I'll do is square root of 0.0444, and that will give me 0.210 or 0.211. So this is 0.211. That is what I have. Now let's find the small t. Remember, the formula for small t is that small t is equal to capital T times number of oscillations. And the number of oscillations we are dealing with here is 20. What I will do is 0.211 times 20, and that will give me 4.22. So the time here is 4.22 seconds. So you can see how we have done that. So I will ask you to do that for, if you're watching this video, do that for 80, do that for 100, and do that for 120. Fill the column for T, fill the column for T, the period capital T, and fill the column for T squared. Okay, so this is how to get the table of values. It's as simple as that. You're not touching the apparatus, there is no need for that. Okay, so I also encourage you to subscribe because I may not do how to plot a graph here, but we have another video to show you how you can plot a graph here after getting the table of values. Let's go to the next question. So in this video, I'm only treating question number 1 and question number 3. Now this is question number 3, and this is the circuit diagram we have for question number 3. Because let's go back to the instruction, what they asked us to provide. Now look at what they asked us to provide for question number 3. You can see resistance box, the key, the voltmeter, the ammeter, connecting wires, and the battery or the accumulator. Now let's go back to the circuit. If you go back to the circuit, this is where your battery is. This is your battery. This is your ammeter. This is your resistance box. Is a variable resistor. This is the key. Now the voltmeter is not here. Listen to me. You are going to set up the apparatus. You are going to set up the connection like this. You are going to set up the connection like this. But if you're actually watching this video, you don't need, if you're paying attention, you don't need this setup to be able to do your practical and to get the 50 over 50 that my students always get. And I have, like I told you, like something A's in both physics and in both WEC and NECO physics practical exams. Let's see the instruction. So you are provided with a battery, an ammeter, a voltmeter, a resistance box, a key, and connecting wires. Set up the circuit as shown in the diagram above. This is the diagram. We have to set up the circuit like this as shown in the diagram above. Okay, let's proceed. Say with the key open, measure and record the EMF E sub 0 of the battery. You see what you're going to do with the voltmeter that's given to you. Okay, and then with the key closed, select the resistance R equal to 1 on the resistance box, read and record the current, evaluate this, and repeat the process. Now look at what I'm going to do. The first thing is, let's identify what we need for this table. There will be a column for R, the resistance, correct. Then there will be a column for current. So we have a column for R, we have a column for current, and then we have a column for the inverse of the current, which is this one. So this table we have 3 columns, okay, and then you have to do the other things. So let's see a sample of the table. This is how the table is supposed to be. And let me show you something. Remember, I told you that us as the teachers to provide two vote accumulator or two 1.5 dry legislation. So if your school, what most schools will do is to bring Tiger Head battery. Each Tiger Head battery has a voltage of 1.5. Each Tiger Head battery has a voltage of 1.5 volts. So if I have two of them, if I have two of them, so this will be 2 times 2, and that will give us this 3 here. So you don't need to do any measurements. If you are giving two Tiger Head batteries, know that the EMF is 3 volt because you are multiplying by 2. So, but remember, is a measured value, so it must be written to at least one decimal place. Mind you, whatever measurement, whatever you are writing here, any value you are writing here must be in decimal place, please. Don't go and write 3 votes. You will get 0 here. You will get 0 because it is not in any decimal place. Okay, please don't go and do that. So that is the value of your EMF. Now let's go. Let's say that we have to open R to 1 ohm. So this my R is 1. So I come here and write 1.0. 1.0. Okay, let's see how we can get the current. Now we are going to apply Ohm's law. Remember, I've told you you can do this experiment without connecting wires. Now take note of this formula. Ohm's law is equal to I. Ohm's law states that V is equal to I times R. Ohm's law states that the voltage is equal to the current times the resistance. So if I know that the supply voltage here is 3 volts, so my supply voltage here is 3 volts. That is your EMF, 3 volts. And then I've opened R to 1 ohm. 1 ohm. Let's find the current. If I make current the subject of the formula here, my current is going to be equal to the voltage over the resistance. That will be my formula. That will be my formula for the current. So let's substitute our values. Let's substitute our values and proceed. Okay, the voltmeter we are working with, voltage we are working with is 3 volts, so I do 3 over 1. So the current here is going to be 3 amperes. Okay, so the current we get when resistance is 1, the resistance is set to 1 is 3 amperes. And remember, this is a measured value, so at least one decimal place. So I will come here and write the current as 3.0. You can use two decimal places and write 3.0. Don't put the unit again. And then you can evaluate the index of the current. The index of current means 1 over the current. So I'm going to do 1 divided by 3. And 1 divided by 3 will give me 0.0333. Okay, I can use 4 decimal places here because this one has to be at least 3 decimal places. It's that simple. So what we do next, let's see when we open the resistor to the resistance box to 2 ohms, for instance. If we open it to 2 ohms, so I come here and write 2.0. The instruction is going to tell you when and where to open it, the particular value of resistor. So this is 2.0 ohms, 2.0. I open it to 2.0. We still apply our formula that current, according to Ohm's law, is V over R. So if I substitute my value, this is going to be 3 over 2. And then this is 3 over 2 is supposed to give us 1.5. So the current here is 1.5 amperes. So what you do here is to find the index of 1.5. That makes 1 divided by 1.5, and that will give me 0.0667. Let me say I'm using 4 decimal places. Okay, so that is just that. I'm going to do this last one and then you do the remaining one. Let's say that we have jumped. We are now told to use a resistance of 4 ohms. So this is 4 ohms. 4 ohms. Now look at what I'm going to do. The current still remains, the formula still remains V over R. So if I do that, I'm going to have 3 divided by 4 now. So you divide 3 by 4. What do you have? 3 divided by 4 gives me 3 divided by 4. That is 0.75. 0.75. So here my current is going to be 0.75. Now look at this issue. 0.75. Look at this issue. The first two I wrote are in one decimal place, but this one is in two decimal places. Don't approximate this to 0.8. No, use 0.75, but just come here, add zero here, add zero here. So you have the same number of decimal places. Okay, so that's what you are going to have. Now, if we fill the column for the index of that, so we're going to do the index of 0.75, 1 divided by 0.75, and that will give me 1 point, that will give me 1.3, 1.333 for decimal places. Okay, so you have watched this up to this point. I believe you have learned something now. I believe you can carry out this. Now, look at what I want you to do. It is something you practice on your own. Let's say the resistance we're using now is 6 ohms. 6 ohms. I want you to do it to finish it. Let's say this is 8 ohms. You have to open to 8 ohms. And then let's say this is 10 ohms. So fill the column for the current using the formula you just learned and then find the index. This is what it's supposed to be. Please, I want you to subscribe to my channel because I will do other things like show you, I will do a video on how to do plot the graph for that question number one, and how to also plot the graph for this one, how to calculate the slope and to find the intercept. Look at the question here. Look at it. We are told here to plot a graph of R against the inverse of current. So I will show you how you can calculate how you can plot a graph in my next video, and how you can go about finding the slope, and then how to determine the intercept, and also how to state precautions for this electricity practical. So please subscribe so that when I do the other videos on all these precautions, even the precautions for question number one, and then how to plot the graph, you watch it. Thank you very much.